Hello student, very good morning to all of you. What did we discuss yesterday? We discussed about the cis hydroxylation and what are the reagents used for obtaining as a cis hydroxylation that we have seen. So in that cis hydroxylation, the starting compound, as we know that the starting compound or the substrate used for cis hydroxylation is what is that? First one is a alkene as a substrate, and that will be treated with as we know that potassium permanganate or osmium tetroxide that gives the cis hydroxylation. These are the two reagents is used to obtain or used to get the cis hydroxylation. These are the things we have seen. When we are using as a cis 2-butene, the resulting product we are getting as a meso compound. If you start with the cis 2-butene, then treated with osmium tetroxide or what we can call it as a potassium permanganate, the resulting compound is always in a meso form. And if you start with the trans 2-butene, the resulting compound obtained is a DL pair that we have seen. Now there is a one disadvantage for this reaction. So disadvantage of this cis hydroxylation. For a cis hydroxylation, the reagent we are using here, the name of that reagent is a potassium permanganate, or we can use osmium tetroxide, OSO4. These are the two reagents generally used to get the cis hydroxylation, and with their stereochemistry we already learned how the product is formed. The one disadvantage for this, suppose we have a starting compound is this one, simplest one, CS3CH, then what we can call it as a, suppose we have this CH and CS3, and the stereochemistry with this we already learned that this 2-butene can exist in a two isomer. One is a cis isomer, second one is a trans isomer, and with this we have learned the product a cis 2-butene that produce meso compound with this reagent. Let us see, suppose here is a potassium permanganate, KMNO4 potassium permanganate. The resulting compound is obtained as this one, CS3 CH OH CH OH and the CS3. This type of the compound is called as a cis diol 1,2 diol, we can call it as a cis 1,2 diol, or we can call it as cis butane 1,2 diol. That is it. But it is very difficult to stop the reaction at this stage. 1,2 diol, this type of the compound for isolation purpose is very difficult, because this further get oxidized with this reagent. Oxidation takes place over here, and further oxidation it produces CS3 C double bond OH plus HO, then C double bond O CS3. That type of the resulting compound is which we are getting, that is a acetic acid. This is a acetic acid or ethanoic acid, that is IUPAC. Same, because this is one of the classical tests for identification of number of what we can call it as the number of hydroxyl group. In case of the carbohydrate, it is useful to find out the position of that carbon double bonds are there. This is one of the method, but it is a disadvantage for the cis hydroxylation. We cannot stop the reaction at this particular step. It further get oxidized to get the carboxylic acid. So that is one of the advantage. Now moving toward the today's discussion, actually let us see here is a trans hydroxylation. So that the point we are going to discuss today is known as a trans hydroxylation. Trans hydroxylation. So what do you mean by the trans hydroxylation? Cis hydroxylation we have learned. Cis hydroxylation means both the hydroxy group are coming on the same phase or coming on the same side. So that type of the 1,2-diol is called as a cis hydroxylation. But now trans hydroxylation, the what type of the reagent for cis hydroxylation? The reagent we generally using potassium permanganate and the osmium tetroxide OSO4. But in case of the trans hydroxylation, here you must remember the for trans hydroxylation the starting compound or the substrate alkene is allowed to react with per acid, organic per acid, and as we know that organic per acid, the name of that suppose as a performic acid. Per acid, it is used per organic per acid. Organic per acids are used for the, and when this organic per acid react with alkane, form the cyclic ether of 3-membered ring, that is called as epoxide. What is called that species form is called as a epoxide. That pi bond is reacted with that per acid and form the species is called as a epoxide. This type of the species is called as a epoxide. This 3-membered cyclic ether, this is a cyclic ether, 3-membered cyclic ether is known as a epoxide. This is a epoxide. Per acid gives as a epoxide, and when hydrolyze it open, this ring get open and we are getting as a trans hydroxylation, and that process is known as a epoxidation. And this the formation of this cyclic member 3-membered cyclic ether, that process is known as a epoxidation. This process is known as a epoxidation, and that the reagent generally used over here per organic acid, or let us see here suppose as a HC double bond O and OH. This is called as a per acid. The name of this per acid is a performic acid. Performic acid. Suppose as a peracetic acid, you replace this compound by CS3, you will get, look at here, observe this structure carefully. What do you see over here? There are the 3 oxygen atom involved in that per acid. This is called as a peracetic acid. Peracetic acid, right? And suppose third one is perbenzoic acid, and as we know that benzoic acid like this, C double bond OH, this is called as a perbenzoic acid. Benzoic acid. This is the name of this reagent, perbenzoic acid, or commercially available acid is called as the metachloroperbenzoic acid. Metachloroperbenzoic acid, MCPBA, metachloroperbenzoic acid. The structure, this is a perbenzoic acid. Only at meta position you can insert or you can introduce only chlorine group. So that is known as a metachloroperbenzoic acid. The full form of that compound is a metachloroperacid. So these are the organic per acid is used for the trans hydroxylation. Now let us see here one suitable example how this product is formed. Let us see here. Generally we are taking as a general starting compound or the substrate, which is, you know that it is a propylene, right? Propylene is a general, and now that will be treated with per acid. Let us see here performic acid, SC double bond OH. This is a performic performic acid, name of this compound. And what is going to happen here? The epoxide is formed here, CS3 CH, then CH2. This type of the compound, this this species is known as a 3-membered cyclic ring is known as a epoxide, and further it is treated, hydrolyze it, and what does it give? It gives CS3 CH, one OH over here and another OH should be other side, so that is called as a trans 1,2 diol. This is a trans 1,2 diol we are getting here, right? This is a trans hydroxylation, and when if you start this compound, now how the mechanisms are taking place over there? The mechanism is as usual, performic acid is treated with, and we will get, let us see the here epoxide form over there. Now how suppose if you start, what will be the stereochemistry behind it? If you start with the trans 2-butene, let us see here trans 2-butene, for the stereochemical purpose we can write trans 2-butene. The structure of trans 2-butene will be Me here, H, here you can write H and Me. This methyl group, they are identical, and no identical group are opposite to the carbon-carbon double bond, and that's why it is termed as a trans isomer. The name of this compound is a trans. Now the name of this compound is a trans 2-butene. This is the name of this compound, trans 2-butene, that will be treated with per acid HC double bond O, then O, CS3. What is going to happen? This is here is a hydrogen atom. Here is a hydrogen atom. Now what is going to happen? This is going to attack on this oxygen atom. This evolve like this, and there will be the formation of this type of the species. I am writing here directly O, then here this C, Me here, then H you can write here, then here this is a sawhorse type of the compound, here H, here is a Me, and when water is attacked over there, H2O attacking from opposite side, and this ring get open, and you are going to get here the compound is like this. Suppose as a here Me, H, OH, this one, let us see here, that goes above one, H and Me, here is a OH. If you draw the structure according to as a Fisher projection formula, Me1 you write here, Me, and then you are going to get the cyclic ether, or what we can call it as a meso compound over there. OH on the same side. This is a meso 1,2 diol. Meso 1,2 diol compound we are getting. So that is a stereo. If you starting compound is a trans 2-butene, then end up with the meso compound. If you start with what is that? If you start with cis-2-butene, let us see here cis-2-butene, as we know that cis-butane can be written like this, double bond, then here Me, here H, then cis, as we know that H. Both the methyl group are on the same side, and then that will be treated with per acid, per metachloro, per benzoic acid suppose. And what is going to happen? There is a formation of the intermediate, that is a epoxide formation takes place here. Me here, H, and then Me here, and the H you can write. And now that will be treated with water, H2O. Is adding from this side, this ring get open, and you are going to get the product like this, Me, then H, here is a OH, then this goes this side. Here is a Me, hydrogen atom, and OH. If you convert this into the Fisher projection formula, how does it look? It looks like this. This is a compound. Here Me you can write here Me, and here OH, H, HO, and here H. That is a DL pair. This one is known as a DL pairs. DL pairs means they are rotating the plane of polarization. Suppose in this case, one you will get R configuration. Suppose if you see here 1, 2 and 3, 1, 2, 2, 2, 3, that is a R configuration. R is converted into as a S. Why S? Because hydrogen atom present at horizontal position. If you look at this one, 1, then 2 and 3, that is also as a R clockwise. So R is converted into as a S. So both are 2S and 3S, means that type of the compound is a DL pair. Means if you start with this, you will get as a DL pair product. So in this way we have completed this point over here, and in a next lecture we will see hydroboration oxidation reaction with their suitable example. So in a exam you should remember what is the main point to remember here as far as cis hydroxylation and the trans hydroxylation. For cis hydroxylation, the reagent is used as a potassium permanganate and the osmium tetroxide. These are the two reagents used to get cis hydroxylation. For trans hydroxylation, as far as the trans hydroxylation, what are the key point to remember for us for this trans hydroxylation? What is the starting material, which is the reagent used, and what type of the intermediate it form, and which is a product form. Because 1 mark question may appear in your exam while treating that olefin with per acid. Mention the transition state. Transition state, with the per acid there is always cyclic epoxides are there. 3-membered cyclic cyclic ether is known as a epoxide, and that process is known as a epoxidation. So this is all about this one. For performic acid, peracetic acid, or the perbenzoic acid, or metachloroperbenzoic acid, these are the some of the reagent is used to get the trans hydroxylation. In the next lecture we will see the hydroboration oxidation reaction, how it takes place with their suitable example we will see tomorrow. Let us stop today here. Thank you. Have a nice day.